Thank you, Mariana. I'll share my screen. So I'm going to show you an example from Greece, but firstly, I will just give you a brief overview of our field test of IB Road to EPC. So we tested the IB Road to EPC in 10 public buildings, and we expect another 7 of them, or 6 of them to be finished shortly. So our intention was to focus on public buildings and have them spread out on all 4 climate zones of Greece in order to test the tool in different conditions and different climatic zones. There were some cases where IB Road to EPC was issued together with the EPC, but they were very like 1 or 2 buildings. So our buildings were spread in the 4 climate zones. We had 1 research building. We had city hall buildings and cultural centers. We also have a museum in Athens, and also 3 educational buildings and 5 buildings in the region of Crete that are mostly administrative buildings. Just a brief introduction for each building. This is the building in Ptolemaida in Western Macedonia. It's a research center. All buildings are of a large area. These 2 are the buildings from the Farsala municipality, the city hall and the cultural center. The Galeo municipality buildings, the city hall, which we are going to explore further, this is the example that I'm going to show you, and the cultural center of Galeo. 2 city halls again of the municipality of Fili. 3 school buildings from municipality of Fili. And the 5 buildings, administrative buildings from the region of Crete. These are finalized now, along with the Benaki Museum, which is this historical building that you see in Athens. It's about a total area of about 6,500 meters. So the example I'm going to demonstrate is of the Galeo City Hall building. It's a building built in 1994. It's used as the municipality offices and has a total area of about 3,886 square meters on a plot of land of 98 square meters approximately. It has 1 underground floor and 4 overground floors, and a relatively complex architectural morphology with some glass elements, curved facade, and different, let's say, architectural elements. The building is located in a corner plot in a densely populated neighborhood of Attica. However, because of a large plot of land, it gets sufficient sun and wind exposure and therefore is ideal for exploiting renewable energy sources. As I said, it was built in 1994 and its systems are well maintained. However, because of this time of its building permit, its energy efficiency is poor, and its systems for heating are with an oil boiler and air pumps with fan coils. For cooling, it features an air-cooled chiller and air conditioning units for ventilation. And regarding the artificial lighting, there were many different types of lamps that were not energy efficient. So its energy class right now is D. It's about, with a primary energy consumption annually of about 416 kilowatt hours per square meter. And as we can see, the most primary energy consumed is for cooling and lighting, and then for heating. So these were the areas where we needed to focus in order to upgrade the building. What was very good is that we had already a renovation strategy that was pre-drafted from the technical staff of the municipality, in which they had already foreseen measures for the insulation of the envelope, the replacement of old windows and facades and glass facades, the replacement of old lamps with LED ones. They wanted to replace the heating and cooling systems with a geothermal heat pump for air conditioning. They also wanted to install automation and building management BMS system. And they also wanted to install photovoltaic panels on the roof, but not very soon, because they had something like a problem with the financing. So they calculated these measures as an energy upgrade scenario, and they found out that they could save around 50,000 euros annually without the installation of the photovoltaic panels in operational costs. So this is the EPC that was already issued for the building. And here on the right is the IB Road to EPC, the third page that was added to the EPC. And now we will see the renovation strategy. It's in Greek, but I think that you can see that on the first step, they decided to replace the heating and cooling systems with a geothermal heat pump. So as we can see, this is the box for the geothermal heat pump and the technical specifications of the measure. And also they installed some automations to prevent the simultaneous use of heating and cooling, to control the temperature of the area, of the water, and some other automations and monitoring indicators regarding the heating and cooling system. So this was the first step. That was as soon as possible, which is 2025. The second step was about the insulation of the envelope with a system of external insulation of 7 centimeters. As you can see, we can also see the preparations for future measures. This was also the case for the first step. The second measure of this step was the insulation of the roof. And the third step is the installation of mechanical ventilation with heat recovery. And also some automations again regarding the indoor air quality, the monitoring of indoor air quality, and the automation of control of the ventilation. The third step was about the replacement of windows and the replacement of old lamps with LED ones, and also some automation measures regarding the presence of people in the building, in the spaces, and an automated control of lighting, taking into account the natural lighting levels in the spaces. And the last one, as I said, the last step was about the installing of photovoltaic panels of 31.60 kilowatts total, let's say, installation, and also some spots for charging of electrical vehicles. So with these measures, the building would go from a D class that is now to an A plus energy class. And if we go more into detail regarding the energy saved, we will see that it's what we saw before in the table that I showed in the presentation. We also have an improvement of the IEQ indicator from 4.3 to 6.6. Which is a very good IQ grade. And regarding the SRI, it went from a 7.6 to a 50.3 grade because of all these measures of the automations that were very advantageous regarding the SRI. And this we can see also is the case if we see the different domains of the SRI, we will see that the monitoring and the ventilation have the higher increased values. And the last, we also did increase the MEPI indicator, where we kind of rate the actual consumption of the building in its present state. So they gave us bills from energy bills and heating oil bills, so we could see how the building is performing in terms of real energy, measured energy performance. And the final page of the renovation strategy is about these consultation boxes on how the users can better influence the energy performance of the building. So this was the case for the City Hall of Egaleo. And I think that's all from my side. If you have any questions, I'm available.
Very good. Thank you, Eleftheria, for showing us also the application in Greece. I think we should also clarify that the measured energy performance, the measured energy use actually module is something that can only be calculated at the states, at the current states, not calculated, can be shown only at the current states because it shows the actual energy use, but it can also be used in the future when you have new data to compare the situation and see what is the actual saving achieved, which is very useful to building owners. One question to you, Eleftheria, how maybe also to the other speakers, how was IB2 EPC received by the building managers?
In general, we received very positive reviews from the building managers, and taking into account that they were highly educated and very experienced staff, technical staff from the municipalities, because we mostly worked with municipalities on the field test. They received it very well. Also, of course, this depends on the different cases of the buildings, because we also had some buildings where they didn't have so much, so many needs in renovation. So this was a good example in terms of the measures that the auditor and the energy expert proposed. But in general, we received very positive feedback.
Thank you. I suggest that we continue with the next presentation. Thank you, Eleftheria. And that will be Alexander Deliyannis from Sympraxis. Alexander is a consultant and project manager with 30+ years of experience in the environmental field. He is also co-founder of the Sympraxis agency and coordinator of the IB2 EPC project, and he will give us an outlook on the perspectives and integration potential of IB2 EPC. So Alexander, the floor is yours.
Thank you very much. Let me share my screen.